Hello everyone, I am Shruti Joshi from the team Deep Drawing, and today me and my team are going to explain thermomechanical study of deep drawing. My team members include Akanksha Nayak, Nitin Aryan, Amisha Raut, Ajit Kumar Kar, Parvati Sharma and Sneha Pandey. Moving on. The deep drawability of steel alloys under conventional press hardening thermomechanical process conditions was investigated. Metallistic stainless steel also were taken to investigation. The hot deep drawability of the MSS alloys was experimentally assessed. The hot deep drawability was evaluated with the resulting maximum drawing depth values. In this work, the hot deep drawability of 3 selected MSS steel alloys as well as its relationship to the thermomechanical process parameters was investigated. The aim of this research was to determine the optical process parameters. However, for the manufacture of complex sheet, the degrees of deformation achievable by cold forming are often insufficient. The disadvantages can be counteracted by a combined forming and thermal treatment, that is, thermomechanical treatment. Over to Parvati.
Thank you, Shruti. Hello everyone. Here I will discuss about what are the materials and method we used in the deep drawing. So the first one is selected mutton size stainless steel alloy. 3 different mutton size stainless steel alloy grades were investigated. These are X12 chromium 13, X30 chromium 13 and X46 chromium 13 alloy. The chemical composition of the investigated alloy, which are determined by using optical emission spectrometer Bruker Tasman Q4. Carbon was the main alloy element whose content was varied. However, the chromium and manganese contents are also increased in line with the carbon content. Then second, definition of the thermochemical process parameter of reference. Optimum process parameters should be mainly defined depending on the metallurgical properties of the alloy investigated. However, some specific parameters are defined according to the essential technological aspects. Therefore, it is important to establish the ranges of the process parameter of interest that would meet the conventional parameters within the framework of technological feasibility. The most relevant process parameters during hot metal forming are the austenization temperature, dwell time, initial forming temperature, strain rate, tool temperature and holding time with a closed tool. Then further will be explained by my other teammates.
Thank you, Parvati. So next is metallurgical analysis based on calculations. Thermodynamic calculations were employed to predict the phase transformations temperatures in the equilibrium. Using the Thermotech FE database was used. For the calculations, the chemical compositions of the alloys summarized. Next, experimental deep drawing test. The MSS sheet materials were evaluated using the method of the deep drawing cup test in order to determine the maximum drawing depth. Circular blanks of the alloys with a thickness of 1.5 mm and a diameter of 170, 180 and 200 mm were austenized and then hot formed into a cup using a drawing punch. The experimental parameters used for the deep drawing test. Due to the broadness of the initial experimental plan, it had to be redesigned in such a way that the results were focused on determining the influence of specific parameters on the maximum drawing depth in a statistical reliable way. Next one is deep drawing simulation with finite element forming. This was done in order to compare these results with the experimentally determined cooling rates and thus validate them. The second was the determination of the resulting plastic strain in the manufactured cup. This determination is important because plastic strain depends mainly on the tool geometry. Therefore, it will be equivalent in the rest of the alloys investigated. Over to Amisha.
Hello everyone. Now I am going to discuss about the results. First one is metallurgical analysis. We determine the phases present in the different alloys in the equilibrium state. The results of the thermodynamic calculations indicate a possible formation of precipitate. This must of the thermodynamic calculations indicate a possible This must of course be confirmed by detailed microstructural characterizations. For now, the intention of the authors is only to show the possible reasons for the thermomechanical behavior of these alloys. Due to the extensive microstructural analysis, the results will, in a subsequent process, the precipitation behavior of magnetite stainless steel as a result of thermomechanical treatment has been investigated and corresponds to the thermodynamic calculations performed. Second one is hot dip probability of the MSS. To perform this analysis, experimental trials were selected where three parameters are kept constant. These are an austenitization temperature of 1050 degrees Celsius, a dwell time of 300 seconds, and a blank diameter of 170 mm. The determined maximum drawing depth values are summarized for the different MSS alloys. Third one is finite element simulation of the deep drawing process. The simulative modeling of the experimental forming process allows estimating the occurring plastic deformation, and in which temperature range this deformation occurs depends on the position in the workpiece. The simulation model corresponds in its geometry to the active parts of the forming tool and in its material properties to the investigated alloys. The simulation was performed exclusively for forming processes after an initial austenizing temperature of 1050 degrees Celsius. Thank you. Over to next.
Moving on to the conclusion. In this work, the hot and deep drawability of the MSS alloys was experimentally evaluated. The maximum drawing depth was used for this purpose. Independently of the process parameters, these alloy grades show a remarkable hot drawability. Nevertheless, due to chemical composition, the hot drawability performance and resulting hardness values are sensible to a variation of these parameters. The optimum parameters for each of the investigated MSS alloys are summarized. That's all from our team. Hope you liked the video. Don't forget to like and subscribe to this channel. Thank you all.